Hey, welcome to another Inventor tutorial. So in this tutorial we're going to look at creating new solids that are linked dimensionally and physically to other solids. There's various different ways of doing this, and in future videos and tutorials I'll show you each individual one in more detail. So let's jump on in and see where we end up. Okay, for this tutorial we're going to look at creating other solid bodies that are linked to another solid body. This is done so that when we enter into the assembly phase that we can bring in several different solid bodies to then create motion constraints for those particular solid bodies. Now there's various different ways of creating these linked assets and these linked bodies. I'm going to try to just briefly show you three of those methods, so that, and then I will do another tutorial. I'll do other tutorials showing them in a bit more depth, but this is just a brief tutorial to look at the three different processes. So I've preloaded a solid body here. It's a basic piston, and I'm going to do a single sort of sleeve, and I will do a shaft. I'll create them all as individual solid bodies, but within this simple part file, this one part file. So to do that, all I'm going to do is basically create a plane somewhere, and then I'm going to just start a two-dimensional sketch like you do quite often. I will then just project the geometry that I want to use, and I'm just going to offset that geometry, and I'll just offset it 1.5 mil. What I'm going to do then is I'm going to offset that again 5 mil. So I've basically got a section that I can extrude up to create the outer sleeve of where the piston is going up and down inside of it. So I can just finish the extrusion, and then I'll just extrude the section, and I will extrude it vertically upwards at 400 mil. Maybe a little bit less than that. Maybe just go 250 for this particular one. Okay. We must remember to create it as a new solid. That's vitally important in this process. And then just click OK. And you can see that we have two solids here now. We've got the piston and the sleeve. So what I'll do for this one, I'm just going to rename it piston instead of solid body 1, and then instead of solid body 2 I'll rename it just sleeve. So to now then what I'll do is I will then start another two-dimensional sketch, and I'm going to project the geometry of the inside section, so it creates the shaft that moves it up and down. That'll be just a solid section, so I'll finish the sketch, and I'm just going to extrude that, and for this one I'm going to extrude it asymmetrically, so I will extrude it into the actual piston and then downwards as well. I'll drag this one back down, so I'll only extrude like 20 mil into the actual piston, and again I'm going to select it as a new solid. We could, if we knew what the dimension inside the piston was properly, we could extrude it all the way up to the surface, but for this example we're just going to extrude it slightly into the piston itself. And then I'm just going to click OK, and I've now created another solid, and I'm just going to basically rename that. I'm just going to call it shaft. So we've now got three solid bodies, piston, sleeve and shaft, which we can now, when we go to, we can actually select them all, and then we can make parts from these components. I won't show you in this particular video. I'll show it in another video, another tutorial of this in more depth. But what will happen then is that these will then be, we can then export these as individual parts on their own part files. The pros and cons of doing this is that, you know, you have ease of drawing. It's just drawing on the same particular component, just modeling up from very small up to a big component. But then that does become the problem, is that you end up having to create more and more solid bodies that you're then going to create the part files from. So in a very complex model, this is not hugely practical. So that's the first way of doing it. So I'll just close that down now. I'll start a new part file. The second way you can do it is you can actually use the derive function. So if I just zoom in here, and we have the derive function here, we can select the derive function, and then we have this window pop up here, and we choose the part that we want to use, and we're going to derive our measurements from this part basically. It will import it into this drawing or this individual part file. So if I just select the part and then open it up, you can see we can actually bring in various different elements that we want. We can either bring, just bring the solid bodies in, we can just bring the parameters in, the different sketches. So I'm just going to bring the solid bodies and the parameters in. And I'll bring in, we've just got the model parameters. There's no other external references for the moment. So I'll just click OK. And you can see it's actually brought it in here as a derived part, as an I part in itself. And it actually contains it. It's already contained within the solid bodies. Now what we can do is, again, we can just basically do our same process again. Set that to 0. We can then start the two-dimensional sketch and do exactly the same as what I was doing before, where I'm going to project the geometry, and then I'll just offset it, do it 2 mil, and then offset that again by 5 mil. Finish the sketch. Can then extrude it vertically upwards, 250 mil. We'll start it as a new solid. We can click OK. So when we come to save this, we can save it as its own individual part, as we normally would. It just has the piston I part in there as a derived part. If we were to double click that particular part within the tree, then it opens up this individual I part on its own account, and actually we can then change our parameters if we wanted to. So our piston radius, where it's 25 mil, we could change it to 30 mil. Click done. Obviously, it's then changed the diameter or the rate of the actual piston. I can then come across to my second drawing, and you can see we've now got a lightning bolt against the eye part itself. And up here, we've got this little lightning bolt with a piece of paper on. I'll just zoom in for that one so you can see it a bit better. So here we have this little icon here, which is our local update. And it's needed to do when we've updated a linked eye part. So if I then click this local update button, you can see everything gets bigger according to the linked dimensions from the derived eye part, the derived piston. So that's another option. And then the third and final way that I want to show how to do this is I'll close down all of these again. This time I'm going to completely start a new eye part. I'm going to start a new two-dimensional sketch. I'm going to basically draw a circle. I'll just draw it and I'll dimension it. And now what I can do here is where I go to edit the dimension. Actually, no, sorry. We have to do this in a slightly different way. So I finish the sketch. If I then come up to my FX parameter list, I can then link to another drawing. In this case, it's going to be my eye part drawing. I can open that up, and then it will give me a list of all the different parameters. And I've the one that I'm particularly interested in, I've actually renamed as piston rad. So I can click and add that one. This message will just selecting a non-exported objects will modify the base component. We'll just click OK for that one. Click OK again. And then in our model parameters here, we've got 213,981. If we just then put in there piston rad, so that our D0 diameter of the circle we've drawn is equal to the piston radius times 2, and obviously it'll be the same diameter. And once I click done, we now have our circle at the right diameter. And what I can do is I'll just go in and edit that sketch now. I will draw another circle and then another circle. Let's just do that one again because I don't think I got the center point quite right. We'll dimension from there to there as 2 mil. And then we'll dimension from there to there as 5 mil. Then I now finish this 2D sketch, and I can extrude this section. We'll do it up 250 mil again, and we can click OK. And there we have the sleeve drawn. And the diameter that we're really interested is linked to the original piston that we drew. Now, if we were to actually open the piston file, you can see down we have the part with actually designing at the moment, and also our piston. If now I come over and change my piston rad to 30 mil again, and then go back to my part that I'm now designing, you can see again we have this local update required. So we'll select that, and straight away you can see that the part that we're currently drawing modifies to that new dimension because the dimension's linked. So there's three ways of doing this, and we'll go into a bit more detail on each of them in future tutorials. So I hope you found that interesting, and again, don't forget to check back for more Inventor tutorials.